what I'm going to do now is try and illustrate that process with just a few, with a really simple food chain and a few screenshots from a software tool. Okay? This is about the simplest food chain you can imagine. It's got 5 steps in this food chain. They go along the diagonal. And so our agent tries to progress along that diagonal, and hopefully it's all disappeared by the time we get to the end. Okay? But each time it makes this step along the chain, there might be new agent added. Okay? And so what we ultimately want to do is say, well, which of these steps along the chain did this agent arise? And don't forget, these steps are not just a new material being added, which might contain some additional... it might be the fact that the heat process didn't quite achieve the kill that it was meant to achieve. It might be that one of the handlers that day had a disease of some kind and transferred material. It's in general, it's quite a complex process to identify those sources, but once we've identified their possibility, we can actually put them together in this kind of model. And so all we're going to do is say, if we know plenty about how these things propagate, how these bacteria or toxins can arise in a chain and they propagate, can we make inference based on an endpoint observation? So here, this is a screenshot from a lovely software tool called Hugin, which you can go outside and try if you like. And so I've coded all that data about this food chain in and made a single observation. The red line is the observation. I've observed an endpoint value, in this case for a population size. And having made that one single observation, you can see I've got my posterior belief, what I believe now about the probability that any of those sources were active. And it says very clearly that there's 96% chance that the first source was active and very little chance that any of the remainder were active, just from a single observation. Sadly, food chains aren't quite as simple as this, but actually many can actually be mapped onto this model quite closely. But that would allow us to make a decision. Going back to that decision maker's process, he would actually be able to, if he decided to actually investigate source 0, okay, the first source, he would have really good reason for investigating source 0 based on that evidence. If we have made a different observation, it's not always as clear as that. So having made a smaller observation in the final population size here, you can see that actually we might want to consider sources 1 and 2 as being active here. We don't know which one, although it does give us some quantitative belief. But it does eliminate the possibility that the other 3 sources were actually significant in the process of providing the final population. Okay? Again, a decision maker could use that information to decide what to do next. Now, you'll see in the bottom left-hand corner of this diagram a very mysterious thing called precision. I've coded this network with very precise information, which allows us to make these nice inferences. And all I want to do is show you actually what happens if that information is not as high precision. I've gone back to the original case where we incriminated the first source from our observation, and now I'm going to change the quality of the information I used to build this chain. In fact, I'm going to lower the quality of the information. So I've gone to low quality information, and that nice, simple decision-making process that we had to start with is now not quite so simple. Even though we've made the same observation, under background conditions where we don't quite know as much, we're left with a choice between 3 possible sources for our problem. Okay? And that shows that a combination of evidence and background information being high quality is essential for this inference process to work. And it's because background information and evidence have both increased in their quality that we can now build this inferential process into food chain management. Now, in a food chain, lots of things are happening all the time, and just this core statistical process is not enough. Lots of other things have to exist alongside this core statistical process for our tool to be operational, to be of use. And that includes things like surveillance monitors, alert systems, anomaly detections, a database, and even decision-making tools that allow probabilities to be converted into the answers to textual questions, if you like. That process can be included into this kind of modelling. Okay? That process of support for decisions, which is what biotracing is about, can be included into a single software tool with all the support for documentation and help that you might expect from a software tool. So in this sense, the statistical inference contributes to a wider process of decision support. And what it actually does, and really the really important thing to think about biotracing, is that it opens up the decision space. Prior to something like biotracing, which identifies a source, decision-making tended to be quite global. We were either on or off. If something went wrong, we stopped, cleaned up, and started again. Actually, what biotracing does, it actually helps you to target your interventions. It says, well, don't stop now, let's just go and look at source 0 and get that cleared up while we're operating. Or it says things like, after a time series of observation, it might say that actually now is the time to maintain this part of the equipment, irrespective of the rest. With really good evidence, you might say now is a good time to find out about the health status of our workers and so on, or our handlers. And in the sense that could lead to a massive reduction in downtime and a massive efficiency in the use of resources for maintenance and management. There is clearly an issue here to do with the passage of liability too. Passing on, having strong evidence for the source outside of your control could lead to a passage of liability. I'm not an expert in the law, so I won't go into that. But you can see how the biotracing idea is meant to help people make decisions. It's meant to translate all this really good science coming from molecular biologists and modelers into something that someone who's got to make a decision can help account for his decisions. And accountability of decisions is far more important than getting them right in a lot of situations. So, to summarise, biotracing combines mathematics and microbiology into a coherent scheme for what is usually called source-level inference. Again, that is a forensic term, source-level inference, that's usually applied to guns coming from crime and DNA left at crime scenes and so on. Biotracing is part of a drive for this improved decision-making. We call this improved decision-making normative. The old-fashioned decision-making, the one that still dominates in most areas of food safety, is called heuristic. That is based on experience, it's based on rule of thumb, and even gut feeling in some situations. We want to try and replace that with this normative, accountable decision-making. The decisions come thick and fast in modern food technology. The development, particularly the product development type process, requires decisions repeatedly and in really fast time. Expertise is spread too thinly in that respect, and normative decision-making will definitely help. There is no doubt that biotracing can sit alongside the traditional schemes like HACCP and risk assessment in food chain management, and actually probably will provide people with incentives. One of the questions is about take-up. How do you get people to take up these new schemes? The best way to do it is to provide them with an incentive so that they have if you like, an edge over their competitors. It makes them better to include biotracing. And certainly biotracing can do that. It can make them feel that they have some kind of advantage. And in general and overall, we hope that biotracing contributes to this overall improved food safety and security, and it does provide a link to threat assessments and so on, which are again of increasing concern in food chain management. Okay. So finally, you've heard from Francis and myself about vulnerabilities and biotracing. What we can't hope to have done in our very short presentations is to have encompassed all the science that went on in all the EU projects that supported this initiative. So just a list of a few of them is there. Okay, that's it. Thank you.
Excuse a slight pause while my battery is changed.